Hello everyone, in this video we're going to learn how to convert an integer from decimal system to another base. So the procedure is that the first step, you want to divide a decimal number by the base. It can be base 2, base 5, base 8, base 16, doesn't matter. The first step is always going to divide the decimal number or the number in base 10 by the base that you will look to convert to. So this can be base 2, base 5, base 8, base 16. Now the second step is that the remainder is the lowest order digit. Is the lowest order digit. In the first step, when you do divisions, you're going to get an integer quotient and a remainder. And the remainder is the one that we're looking for in the second step. Now for the third step, we're going to repeat the first two steps until no divisor remains. Until no divisor remains. And the last step is to obtain the results. You write the integer portions from bottom to top to get the results. Portion from bottom to top to get the results. So let's consider the following example. I want to convert the number 13 from base 10 to binary. Now what I'm going to do is I'm going to take 13 divided by 2. Why divided by 2? Because we are working to convert it to the binary system. Now when you do this calculations, you're going to get 6 for the integer quotient, and the remainder is 1. So 6 with the remainder 1. Now, you can do the divisions if you want to, the regular divisions that you learned in the past to get the remainder. So that is 2 here. This is 13. So 2 going to 13, you have 6 times. So 6 times 2 is 12. You do the subtractions. And 13 minus 12 is 1. So the remainder is 1. Then the next step is to take this integer 6 divided by 2, and you get 3 for the answer, and for this calculation you get no remainder, or the remainder is equal to 0. Next, you're going to take 3 divided by 2, you get 1 with the remainder of 1. And then you do 1 divided by 2, so 1 cannot really divide it by 2, so the integer quotient is going to be 0 with the remainder of 1. Because the integer's quotients or the divisor is now equal to 0, therefore you stop the procedure and you write the remainder portions from bottom to top to get the results. So 13 in base 10 is equivalent to 1101 in base 2. Now let's do another one, but in base 5 and see what happened. So it's going to be very similar procedures here. So you want to convert 52 in base 10 to base 5. Because we want to convert that into base 5, you're going to take 52 divided by 5, and you're going to get 10 with a remainder of 2. You take 10, you divide it by 5, you get 2 with the remainder is 0. And you take 2 divided by 5, you cannot really divide it by 5, so the divisor is 0 with remainder 2. So 52 in base 10 is equivalent to 202 in base 5. Again, what you want to do is you go in from the bottom up, and you take all the remainder and put them together like that. Now in the next example, I want to convert a number from base 10 to hexadecimal. So we're going to convert the number 177130 from base 10 to hexadecimal, which is base 16. You're going to take 177,130 divided by 16, and if you use a calculator, you're going to get 11070 with a remainder of 10. Another way to look at the remainder is that if you take this number, multiply with 16 and do a quick subtraction, you will see the remainder is equal to 10 instead of doing the calculation that I show here. Okay, so this result I get from using the calculator, and then to get the remainder, what you can do is you're going to take 11070 times 16, and this number you got gets subtracted from the original number, and you're going to get 10 for the answer, and 10 in this case is going to be the remainder. Now, next number is 11070 divided by 16. Use a calculator. You're going to get 691 with a remainder of 14. Again, how would you get 14? So similar calculation as before. You're going to take this number, 691, multiply with 16, and it gets subtracted from 11070, and you're going to get 14 for the remainder. Next, you're going to take 691 divided by 16, and you're going to get 43 with a remainder of 3. Again, how would you get 3? So you're going to take the number 691 minus 43 times 16. You should get 3 for the answer. Next one, 43 divided 16. You're going to get 2 with a remainder 11. And you're going to take 2 divided by 16. So 2 cannot really divide by 16, so you get 0 for the integer quotient, and the remainder is still 2. Alright, so the difference between order system and base 16 is that you have to make the comparisons and convert the number 10, 14, 11 into letters. So 10 is equivalent to letter A, 14 is equivalent to letter E, and 11 is equivalent to letter B. And then to get the result, we're going to start from the bottom, take all the remainder and put them together to get the final results. Thus, the number 177,130 in base 10 is equivalent to 2B, 3E, A in base 16. And that's it for this video. In this video, we look at different examples in which we convert an integer from decimal system to another base. In the next video, we're going to see example related to conversions of fractions from decimal to another base.